Good morning everyone, and to our research advisor, Dr. Galman. I'm Mark Lawrence Sotto, and together with me are my fellow researchers, Mr. Elgin Collamat, Mr. Gabriel Fuentes, Mr. John Christian Ira, and Mr. Lawrence Daniel Santos. We are the Group 5 of Grade 12 St. James. To proceed, our quantitative study is entitled Determining the Effect of Exhaust from Car Fuels on the Growth of Camote Plant, or Pomea batatas. Without further ado, I will now present the Chapter 1. In today's time, air pollution continued to worsen the health of the plant ecosystem. According to Brown 2019, this is due to the emission of greenhouse gases such as carbon dioxide, methane, and chlorofluorocarbons. The main sources of air pollution include the production of electricity in power plant and the automobiles via fossil fuel combustion, based on Andaya 2008. This also includes the various forms of transportation such as automobiles, airplanes, ships, and trains. It is stated in the Chief Sources of Pollution 2017 and from Zulueta and Liwag 2006. These emissions affect the human health and also the plants along the roadside, specifically this one. Labeled as the poor man's staple food, sweet potato, or also known as camote in the Philippines, is considered a favorable root crop because of its abundance, nutritional value, and adaptive capability. This is according to the Bureau of Agricultural Statistics in Quezon City 2007 and to the Center of Research and Communication 2010. With that, the researchers have this rationale of the study. The study aimed to determine the effect of exhaust from car fuels, specifically unleaded, premium, and diesel, on the growth of camote plant. In the statement of the problem, the main problem asks, what is the effect of exhaust from car fuels on the growth of camote plant? Specifically, the researchers sought to answer to the following questions. First, what is the profile of the camote plants before and after the exposure to the exhaust of car fuels in terms of leaf color, stem length, leaf width, and lifespan of the plant? Second, which among the exhaust from car fuels affect the growth of camote plant the most and the least? Third and the last, is there a significant difference on the stem length and leaf width of camote plant exposed to unleaded, premium, and diesel fuel? In the theoretical framework, the first theory to be used to support the study is the invisible theory of plant damage. In the article of Thomas M., 1956, the invisible injury theory of plant damage was mentioned originally by Raman and Sorauer, which was later developed by J. Stoklasa in 1923, who believed that the toxic gases in the atmosphere would result in harsh damage to vegetation even though the concentration was below the level necessary to produce visible lesions on the leaves of the plant. This suggests that the gasoline fumes can cause damage to plant such as camote. The second theory is the optimal defense theory. The optimal defense theory of chemical defenses, outlined by Mackey in 1974, states that the plants can defend itself from chemicals, but it would negatively affect the leaf's morphology and function. This is based from the article of Wolinska and Behrens in 2019. This suggests that the plants may defend against the chemicals, but the leaves would drastically affected negatively. The third and last theory is the plant nutrition theory. The plant nutrition theory of Aristotle to Liebig, according to Shernan 1933, Aristotle had taught that the food plant is not that simple, but rather it is composed of various combinations of the four elements: water, air, earth, and fire. Gases are absorbed by the plants through their pores on the leaves, and that the car exhaust can really damage the plant because of its toxicity. In the conceptual framework, the researchers used the IPO model, or the input, process, output pattern. In the input box, this presents the independent variable car fuel's exhaust and its attribute unleaded fuel, premium fuel, and diesel fuel. Next is the dependent variable growth of Camote plant and its attribute stem length, leaf width, leaf color, and lifespan of the plant. Next, on the process box, this shows the research design used, which is experimental, followed by the methodology. The under of it includes the preparation of systems, which are the Camote plants and the exhaust simulation setup. Next is the exposition of Camote plants to exhaust of car fuels, followed by the gathering of data, analysis of data, and the statistical treatment. In the descriptive statistics, the researchers used the graphical tool tables, and on the inferential statistics, F-test or one-way ANOVA is used. And lastly, for the output box, this presents the effect of exhaust from car fuels on the growth of Camote plant. May I call on Mr. Collamat to continue the remaining chapter 1.
Thank you, Mr. Lawrence Sotto. Good day, everyone. I am Mr. Collamat, and I am here to discuss the remaining parts of chapter 1, which are research hypothesis, definition of terms, significance of the study, scope, and delimitation. First, I am going to talk about research hypothesis. Our first null hypothesis states that there is no significant difference on the stem length of Camote plants exposed to unleaded, premium, and diesel fuel. Its alternative hypothesis is there is a significant difference on the stem length of Camote plants exposed to unleaded, premium, and diesel fuels. Our second pair of null hypothesis states that there is no significant difference on the leaf width of Camote plants exposed to unleaded, premium, and diesel fuel. Its alternative hypothesis is there is a significant difference on the leaf width of Camote plants exposed to unleaded, premium, and diesel fuel. Now, let's jump to definition of terms. The definition of terms are divided into two, identified as conceptual and operational. First is exhaust gas. It is conceptually defined as a waste generated in the engine cylinder after burning of the air and petrol mixture in the petrol engine, or air and diesel mixture in case of diesel engine. It is thrown out of the engine cylinder to the atmosphere through the exhaust system on the vehicle, according to Maddewall. On the other hand, Fetzer state that it is partially burned gases, such as those given off by most automobiles when they are running, while Mwangi said that is pollutant gases that are generated by engines, such as nitrogen oxides, carbon oxides, hydrocarbons, and particulate matter. Its operational definition is measured by the smoke produced from combusting 10 ml of each fuel. Second is Camote plant group. It is conceptually defined as the outcome of cell division, enlargement of the new cells, and their differentiation into different types of tissues, as stated by Koratkar. On the other side, Brucken and Morozoa stated that increasing of plant volume and mass with or without formation of new structures such as organs, tissues, cells, or cell organelles. While the National Council of Educational Research and Training defined it as an irreversible, quantitative, increasing in size, mass, and volume of a plant or its parts, including the events leading to leaf formation and the increase in height of a plant. Its operational definition is it measured through the leaf color, leaf width, stem length, and lifespan of the Camote plant after uprooting. Lastly, the lifespan of the plant. It is conceptually defined as the length of time it takes from the beginning of development until death, as said by Boundless. On the other note, the verses mentioned the time period from establishment until no lived part remains of the respective individual, while Plant Lifespans blog said that the cycle of a plant's life from seed germination to death. Its operational definition is defined as the lifespan was measured by the number of days the exposed plants lasted after uprooting. And now, let's talk about significance of the study. This study holds various information that may be used by the following people or agencies to enhance their knowledge about the effects of car fuels to the growth of plants, and to be informed what are the different effects of a car fuel to the growth of plants. This study benefits the following. To the automobile drivers, they will know the different effects of the fuel that they use daily to the growth of plants that has been planted along the roadsides. To the local and national health agencies, they will know what the fuel is the most toxic. They may also attain some new information about the fuels and its effect to the growth of plants, that many human consumers may consume the infected plants. To the roadside farmers, they will have more knowledge about the plants that they are planting along the roadsides and the effects of different car fuels in their plants. They may have further information about the plants when they use this study as their reference in planting along the roadsides. To the fuel companies, they may use this study as a raw material to its production of fuels that has an effect on the growth of plants along the roadsides where many people make it as a business or food in their daily life. To the future researchers, they will have a concrete background of the study that is related to the growth of plants and the effects of exhaust from car fuels on the growth of plants. They may also use this as a tangible reference when they conduct a similar or related study. Lastly, for Chapter 1 is Scope and Delimitation. This study investigated the effects of car exhaust from several car fuels on the growth of Camote plant, scientifically known as Pumea batatas. It was conducted in a small lot soil at Saog, Marilao, Bulacan. The three types of car fuels were limited only to unleaded, premium, and diesel. These were gathered by the researchers from Petron, Bukawi. Since according to Philippine Department of Energy, Petron Corporation continues to lead the Philippines fuel market with a 27.8% market share. Moreover, the amount of every type of gasoline combusted was 10 ml. The Camote plants were picked from one mother plant, and the researchers' criteria in choosing Camote plants must have leaves, green or violet, to be measured regardless of its width, and it must have main stem regardless of its length. The soil that was used for each setup was the soil from the researchers' backyard. There were 2 samples of plants for each exhaust, and also 2 samples for controlled plants for one setup in case something happens to one of the Camote plants. The researchers conducted 3 setups to ensure and strengthen the results of the study. So there were 3 setups which had 8 plants per setup. The Camote plants were watered once a day after exposing it from the exhaust. Stem length, which refers to the length of the main stem and width of the chosen leaf, marked with an ink, of the Camote plant were measured in millimeters for the first and 5th day. Then, the color of the leaves was observed the same days as it was measured. Lastly, the lifespan of the plant was monitored from the day the plant was uprooted until it died. The experimentation was conducted from November 2019 up to January 2020. Now, may I call Mr. John Christian Ira for the Chapter 3.
Thank you, LJ Collamat. And now, I'm John Christian Ira, and I'm here to present Chapter 3, which is Methods and Procedures. This chapter shows the research design used in this study. It also provides the process of preparation of the system, exposition of camote plots from car exhaust, gathering of data, data analysis, and the statistical treatment used in this study. True experimental design was used in this study in order to determine the effects of unleaded, premium, and diesel on the growth of camote plant. 3 setups were performed for each exhaust, including the control. There are 2 plants for each exhaust, also for the control. For the first setup, it was exposed from November 28, 2019 to December 2, 2019. In the second setup, it was exposed from December 16, 2019 to December 20, 2019. And for the last setup, it was exposed from January 10, 2020 to January 14, 2020. From one of the researchers' backyard, they plucked the camote plants from a mother plant by cutting the stems and then planted it in a small lot soil. After the researchers planted the camote plant in a small lot soil, the researcher who owned the backyard watered it for 1 week. It was watered for 1 week so the roots will be developed. After 1 week, the researchers proceeded with the exposure. For every type of fuel, there are 2 plants. These were organized into 4 groups. 1 unleaded, 2 premium, 3 diesel, and 4 controlled. Plants A and B were exposed from unleaded fuel. Plants B and C were exposed from premium fuel. And plants E and F were exposed from diesel fuel. Therefore, 24 camote plants were used for this setup to make the data accurate and precise. Exhaust simulation setup. 4 boxes were used to cover the 8 camote plants. The 4 boxes has the same size, 45 centimeters in height, 27.5 in width, and 42 centimeters in length. The boxes were sealed by a packing tape so the excess exhaust will not come out. A hole was made in each side of the box, wide enough to insert 0.5 meters of long, clear, thick plastic tube with a diameter of 13 millimeters. The other side of the tube was inserted into the spout of the stainless kettle. 10 ml of car fuels, which is unleaded, premium, and diesel, were put inside the kettle, and the kettle was compounded over a 1 plastic amount of burning coal. 3 kettles were used for the container of the car fuels. This allowed the exhaust from the car fuels to be transported through the tube into the box, thus exposing the plants inside the box except for the controlled plants. Exposition of camote plants to the exhaust from car fuels. The groups of camote plant were exposed to the exhaust simultaneously for 20 minutes. The gases were heated in a kettle with coals, which then produced an exhaust that traveled through the plastic tube connected to the boxes. The samples were exposed to the exhaust from the car fuels until the end of their lifetime. However, the control setup, which was not exposed to any exhaust, was only covered with a box to prevent any contamination. The differences in effect to the samples were monitored by the researchers and was recorded. Also, the researchers watered the plants every after exposing it from the exhaust of car fuels. Data gathered. The researchers used the tape measure in order to get the measurement of the leaf's width from left to right of its blade near the base in millimeters. The length of the main stem was measured from the cell to the plant's terminal bud in millimeters and measured for 5 days. The color of the plant's leaf was observed for 5 days. Also, the lifespan was measured when it died in days after uprooting. Analysis of data. The data gathered were put into tables that allowed them to know the different after exposing it to the exhaust from unleaded, premium, and diesel. The growth of Camote plant in terms of its leaf width, main stem, color of the leaf, and the plant's lifespan were compared to each exhaust, revealing which of them has the most and least effect. Statistical trait. One-way ANOVA was the tool that was used by the researchers in order to determine the effect of car exhaust on the growth of Camote plant. This has been John Christian Era, and now we have Lawrence Santos for Chapter 4.
Good day, I'm Lawrence Santos and I'm here to discuss the summary findings of the research. First, what is the profile of the Camote plants before and after exposure to car fuels in terms of color of the leaves, length of the main stem, width of the leaves, and lifespan of the plants? A total of 24 Camote plants were used in 3 setups, and 18 out of those 24 Camote plants were exposed to exhaust of car fuels, and 6 out of those 24 were not exposed to any car fuels. Now let's proceed to the color of the leaves. In setups 1 to 3, 16 out of 18 Camote plants' leaf color were green, and 2 out of 18 were violet before exposure to exhaust of car fuels, and 6 out of 6 of controlled Camote plants' leaf color were green and were not exposed to any exhaust of car fuels. Now, after 5 days of exposure, 7 out of 18 Camote plants' leaf color retained its original green color, and 6 out of 18 turned to brown color, and 5 out of 18 turned to yellow-green color, while all the controlled leaf color retained its original green color. Now, the length of the main stem. In setups 1 to 3, 6 out of 6 Camote plants exposed only to the exhaust of unleaded fuel had decreased on its stem length. And for the Camote plants exposed only to the exhaust of premium fuel, 5 out of 6 had decreased on its stem length, and only 1 out of 6 had retained its original stem length. And for the Camote plants exposed only to the exhaust of diesel fuel, 6 out of 6 had decreased on its stem length. And lastly, for the Camote plants that were not exposed to any exhaust, 6 out of 6 had increased on its stem length. Now, for the width of the leaves, in setups 1 to 3, 5 out of 6 of the Camote plants exposed only to the exhaust of unleaded fuel had decreased on its leaf width, and only 1 out of 6 had increased on its leaf width. And for the Camote plants exposed only to the exhaust of premium fuel, 5 out of 6 had decreased on its leaf width, and only 1 out of 6 had retained its original leaf width. And for the Camote plants exposed only to the exhaust of diesel fuel, 6 out of 6 had decreased on its leaf width. And for the Camote plants that were not exposed to any exhaust, 6 out of 6 had increased on its leaf width. Now, for the lifespan of the plant, in setups 1 to 3, after being uprooted, the longest lifespan of the Camote plants that were exposed is 6 days, and the shortest is 0. And now, for the Camote plants that were not exposed to any exhaust, the longest lifespan is 9 days, and the shortest is 7 days. The second finding of the research: which among the exhausts from car fuels affected the growth of Camote plant the most and the least? The car fuel that had the most effect on both length of the main stem and leaf width is diesel, with an average decrease of 4 mm on the length of the main stem and an average decrease of 8 mm on the leaf width. And the car fuel that had the least effect on the growth of Camote plant on both length of the main stem and leaf width is premium, with an average decrease of 2.67 mm on the length of the main stem and an average decrease of 2.83 mm on the leaf width. The third finding of the research is there a significant difference on the stem length and leaf width of Camote plants exposed to car fuel. Both had no significant difference, since the computed F value for the length of the stem is 0.58427 and it's less than the F critical value, which is 5.1432. And for the leaf width, the computed F value is 1.8385
and is less than the F critical value, which is 5.14325. May I call on Mr. Gabriel Fuentes to discuss the conclusion of the research.
Good day everyone, my name is Gabriel Fuentes and I am here to present the conclusions for this study. These conclusions were based on the researchers' insights regarding the findings of the study, and are supported by literatures and studies referenced in the paper. Based on the data gathered, the researchers came to 6 conclusions. Conclusion number 1. The camote plants change color negatively after exposure to car fuel exhaust. This is supported by a study done by Zafar and Company in 2016, which observed that exposing V. rosea and R. tuberosa seedlings to generator exhaust pollutants resulted in leaf chlorosis and necrotic brown lesions. Conclusion number 2. The camote plant's main stem length shortened after exposure to car fuel exhaust. This is also supported by the reduction in growth of V. rosea and R. tuberosa seedlings after being exposed to exhaust gas, which was also observed in the study done by Zafar and Company in 2016. Conclusion number 3. The camote plant's leaf width diminished after exposure to car fuel exhaust. This is supported by a study conducted by Gustin in 2016, which observed that exposing plants to air pollutants had adverse effects on leaf structure. Conclusion number 4. The camote plants have a shortened lifespan after exposure to car fuel exhaust. A study by Bell and Company in 2011 concluded that fumigation on plants resulted in premature plant senescence or aging process. Another study conducted by Saxena and Kulshesta in 2016 observed the negative impacts of gasoline exhaust pollution on biochemical and physiological characteristics of plants. These characteristics were used as indicators of plant lifespan. Conclusion number 5. Diesel fuel exhaust has the most effect on the growth of the camote plants, while premium fuel exhaust has the least effect. According to Schupak 2014, gasoline with higher octane levels produce less carbon emissions. This indicates that premium fuel, which has an octane level of 91 to 93, produces less carbon than diesel fuel, which has a level of 40 to 45. And finally, conclusion number 6. There is no significant difference on the effect of exhaust from different car fuels on the stem length and leaf width of the camote plants. A study in 2011 reveals that automotive emissions can have direct serious impacts on the growth of plants by reducing their length. These emissions come from various auto exhaust pollutions such as diesel, unleaded, and premium fuel exhausts. In the same manner, exhaust from many fuels produces automotive pollution that affects plant growth by reducing leaf size. These exposures can also lead to plant size reduction and death, according to Saadabi and Al-Amin in 2011 and Melgarejo in 2016. Thank you for listening. Once again, I am Gabriel Fuentes. And now, may I call on Mr. Mark Lawrence Sotto to present the recommendations of the study.
Thank you, Mr. Gabriel Fuentes. And now for the recommendations. On the verdict of the findings and conclusions, the researchers recommended the following. First is that the automobile drivers should be warned that diesel is the most toxic fuel that affects the growth of the plants on the environment. Second, the local and national health agencies are advised to promote to the public the lessening of fueled automobile usage due to their negative effects on the growth of plant. Third is that roadside farmers are advised to adjust their plants away enough to prevent direct exposure from vehicles passing by. Fourth is that fuel companies are advised to make an alternative fuel that has a lesser effect on plants. And for the future researchers, it is recommended to use more accurate measuring tools to have accurate and precise data. Conduct a study with the other types of fuels and their effects on the plant's growth. The researcher may use an engine to control the extraction of exhaust from fuels. And lastly, the researchers also suggest investigating the other properties of growth of plants. That's all. Thank you. Again, I'm Mark Lawrence Sotto.
We are Group 5, Caritas Christi Urgent Rules.